Welcome to Uma's Education. Today we are going to see the introduction of rational numbers part 2. We can see the remaining properties of rational numbers now. Definition of commutative property. Let a and b be any two rational numbers. Now we will find out whether ab is equal to ba, where asterisk symbol represents the basic arithmetic operation. Commutative property of addition. To check if the set of rational numbers is closed under the commutative property of addition, we can take two rational numbers 7 by 5 and 5 by 15. Now we will add 7 by 5 and 5 by 15. When we cross multiply, we get 7 into 15 plus 5 into 5 divided by 15 into 5. When we multiply, we get 105 plus 25 divided by 75. When we add, we will get 130 by 75. Now we will add 5 by 15 plus 7 by 5. When we cross multiply, we get 5 into 5 plus 15 into 7 divided by 15 into 5. When we multiply, we get 25 plus 105 divided by 75. When we add, we will get 130 by 75. Thus 7 by 5 plus 5 by 15 is equal to 5 by 15 plus 7 by 5. Therefore, commutative property holds true for addition of rational numbers. Commutative property of subtraction. To check if the set of rational numbers is closed under the commutative property of subtraction, we can take two rational numbers 4 by 3 and 3 by 3. Now we will subtract 4 by 3 and 3 by 3. As the denominators are equal, we can directly subtract. So we will get 4 minus 3 by 3, which is equal to 1 by 3. And now on the right hand side, 3 by 3 minus 4 by 3. Now same, the denominators are equal. So we can subtract directly 3 minus 4 by 3, which is equal to minus 1 by 3. Thus 4 by 3 minus 3 by 3 is not equal to 3 by 3 minus 4 by 3. Therefore, commutative property does not hold true for subtraction of rational numbers. Commutative property of multiplication. To check if the set of rational numbers is closed under the commutative property of multiplication, we can take two rational numbers 3 by 2 and 2 by 6. Now we will multiply 3 by 2 and 2 by 6, which is equal to 3 into 2 by 2 into 6 is equal to 6 by 12. Now we will multiply the right hand side 2 into 6 into 3 by 2, which is equal to 2 into 3 by 6 into 2 is equal to 6 by 12. Thus 3 by 2 into 2 by 6 is equal to 2 by 6 into 3 by 2. Therefore, commutative property holds true for multiplication of rational numbers. Commutative property of division. To check if the set of rational numbers is closed under the commutative property of division, we can take two rational numbers 1 by 2 and 2 by 2. Now we will divide 1 by 2 and 2 by 2, which is equal to 1 by 2 into 2 into 2 is equal to 1 into 2 by 2 into 2 is equal to 2 by 4. In the right hand side, 2 into 2 divided by 1 by 2 is equal to 2 by 2 into 2 by 1, which is equal to 2 into 2 by 2 into 1, which is equal to 4 by 2. Thus 1 by 2 divided by 2 by 2 is not equal to 2 by 2 divided by 1 by 2. Therefore, commutative property does not hold true for division of rational numbers. Definition of associative property. Let a, b and c be any three rational numbers. Now we will find out whether a and bc is equal to a, b and c, where asterisk symbol represents the basic arithmetic operation. Associative property of addition. To check if the set of rational numbers is closed under the associative property of addition, we can take three rational numbers 3 by 5, 1 by 5 and 11 by 5. Now we will calculate 3 by 5 plus open bracket 1 by 5 plus 11 by 5, which is equal to 3 by 5 plus 1 by 5 close bracket plus 11 by 5. First we will calculate the left hand side 3 by 5 plus open bracket 1 by 5 plus 11 by 5, which is equal to 3 by 5 plus 1 plus 11 by 5. As the denominators are equal, we no need to do any cross multiplication. Now we will add 3 by 5 plus 12 by 5, which is equal to 3 plus 12 by 5, which is equal to 15 by 5. Now we will calculate the right hand side 3 by 5 plus 1 by 5 close bracket plus 11 by 5, which is equal to 3 plus 1 by 5 plus 11 by 5. which is equal to 4 by 5 plus 11 by 5 is equal to 4 plus 11 by 5. Now we will get the final answer 15 by 5. Hence prove that LHS is equal to RHS. Thus 3 by 5 plus open bracket 1 by 5 plus 11 by 5 is equal to open bracket 3 by 5 plus 1 by 5 plus 11 by 5. Therefore associative property holds true for addition of rational numbers. Associative property of subtraction. To check if the set of rational numbers is closed under the associative property of subtraction, we can take three rational numbers 1 by 2, 3 by 2 and 8 by 2. Now we will calculate 1 by 2 minus open bracket 3 by 2 minus 8 by 2, which is equal to open bracket 1 by 2 minus 3 by 2 minus 8 by 2. Now first we will calculate only LHS 1 by 2 minus open bracket 3 by 2 minus 8 by 2, which is equal to 1 by 2 minus 3 minus 8 by 2. Now we have the same denominator, so we no need to do any cross multiplication. Now we will get 1 by 2 minus of minus 5 by 2. Minus of minus will become plus. So we will get 1 by 2 plus 5 by 2, which is equal to 6 by 2. This is the value of LHS. Now we will calculate right hand side 1 by 2 minus 3 by 2 close bracket minus 8 by 2, which is equal to 1 minus 3 by 2 minus 8 by 2, which is equal to minus 2 by 2 minus 8 by 2. So we no need to do any cross multiplication as the denominators are same. Minus 2 minus 8 by 2, which is equal to minus 10 by 2. So LHS and RHS is not equal. Thus 1 by 2 minus open bracket 3 by 2 minus 8 by 2 is not equal to open bracket 1 by 2 minus 3 by 2 minus 8 by 2. Therefore associate property does not hold true for subtraction of rational numbers. Associate property of multiplication. To check if the set of rational numbers is closed under the associative property of multiplication, we can take three rational numbers 2 by 3, 4 by 3 and 6 by 3. Now we will calculate 2 by 3 into open bracket 4 by 3 into 6 by 3, which is equal to open bracket 2 by 3 into 4 by 3 into 6 by 3. Now we will calculate only in left hand side. 2 by 3 into open bracket 4 by 3 into 6 by 3 is equal to 2 by 3 into 24 by 3, and we will get the final answer 48 by 3. Now we will calculate the right hand side. Open bracket 2 by 3 into 4 by 3 into 6 by 3 is equal to 8 by 3 into 6 by 3, which is equal to 48 by 3. Thus 2 by 3 into open bracket 4 by 3 into 6 by 3 is equal to open bracket 2 by 3 into 4 by 3 into 6 by 3. Therefore associative property holds true for multiplication of rational numbers. Associative property of division. To check if the set of rational numbers is closed under the associative property of division, we can take three rational numbers 2 by 4, 4 by 4 and 6 by 4. Now we will calculate 2 by 4 divided by open bracket 4 by 4 divided by 6 by 4, which is equal to 2 by 4 divided by 4 by 4 closed bracket divided by 6 by 4. Now we will calculate the left hand side 2 by 4 divided by open bracket 4 by 4 divided by 6 by 4. Where there is a division sign, we have to change that as a multiplication sign and reciprocal the next number. So we will get 2 by 4 divided by open bracket 4 by 4 into 4 by 6. So we will get 2 by 4 divided by open bracket 4 into 4 by 4 into 6 is equal to 2 by 4 divided by 16 by 24, which is equal to 2 by 4 into 24 by 16 is equal to 68 by 64. When we simplify, we will get 3 by 4. 3 by 4 is the final answer of LHS. Now we will calculate RHS. 2 by 4 divided by 4 by 4 close bracket divided by 6 by 4 is equal to 2 by 4 into 4 by 4 close bracket divided by 6 by 4, which is equal to 2 into 4 by 4 into 4 close bracket divided by 6 by 4 is equal to 8 by 16 divided by 6 by 4, which is equal to 8 by 16 into 4 by 6 is equal to 32 by 96. When we simplify, we get 1 by 3. So LHS is not equal to RHS. Thus 2 by 4 divided by open bracket 4 by 4 divided by 6 by 4 is not equal to 2 by 4 divided by 4 by 4 close bracket divided by 6 by 4. Therefore, associative property does not hold true for division of rational numbers. Distributive property of multiplication or addition. Let A, B and C be any three rational numbers, then the distributive property of multiplication or addition states that A into B plus C is equal to A into B plus A into C. For example, let A is equal to 1, b is equal to 2 and c is equal to 3, we will get 1 into a bracket 2 plus c is equal to 1 into 2 plus 1 into 3. First you can calculate the left hand side, so we will get 1 into 5 which is equal to 5. And now we will calculate the right hand side, so we will get 1 into 2 is equal to 2 and 1 into 3 is equal to 3. So 2 plus 3 is 5. So 5 is equal to 5. So LHS is equal to RHS. This proves that a into bracket b plus c is equal to a into b plus a into c. Distributive property of multiplication over subtraction. Let a, b and c be any three rational numbers, then the distributive property of multiplication over subtraction states that a into b minus c is equal to a into b minus a into c. Let a is equal to 3, b is equal to 1 and c is equal to 3, we will get 3 into bracket 1 minus 3 is equal to 3 into 1 minus 3 into 3. We can first calculate the left hand side. 3 into 1 minus 3 is equal to minus 2. So we will get 3 into minus 2 is equal to minus 6. Now we will calculate the right hand side. 3 into 1 is equal to 3 and 3 into 3 is equal to 9. 3 minus 9 is equal to minus 6. So LHS is equal to RHS. So this proves that a into b minus c is equal to a into b minus a into c. Thanks for watching. Please like, share and subscribe the channel.